Good morning, good afternoon, good evening, whatever the case might be, maybe, whatever the case may be, we are back and better than ever, and we are going to solve quadratic equations by factorisation. Note the absence of the z. We shall live with that. Let's get right to it, shall we? It's fascinating stuff. And the way solution by factorization is dependent on understanding of the Null Factor Law. And all that the Null Factor Law states is that if I am multiplying two things, two numbers, a times b equals 0, one or both have to be equal to 0. It doesn't matter. Like if a was 7 and b was 0, 7 times 0 equals 0. Doesn't matter what a is. 86 times 0 is 0. 1 kabillion, that's not a real number, I know, but 1 kabillion times 0 is equal to 0. It doesn't matter. So this equation is true if b is equal to 0, or using the same argument if a is equal to 0. So that's what we base the null factor law on. And it seems pretty simplistic, but this is key. Your equation must be equal to 0. It doesn't work with anything else, like a, b equal to 3. You just can't say, well, b is equal to 3. Either a equals 3 or b equals 3. No, because that would be very dependent on what b is. In other words, if a was 3, b must be 1. That's the only choice for this to be true. But with 0, it doesn't matter which one. When it's equal to 0, either a can be 0 or b can be equal to 0 for the equation to be true. All right, so solve for x using the null factor law. I have 3x multiplied by x minus 5. Well, either 3x could be equal to 0, or x minus 5 would be equal to 0. Divide by 3, x equals 0, or x equals 5. And let's convince ourselves. If x equals 0, 3 times 0 is 0, and 0 times 0 minus 5. So 0 times negative 5 is 0. I don't even have to go that far, because I have 0 times something. 0 times anything is equal to 0. And when x equals 5, my 0 occurs here. 5 minus 5 is 0, right? And x equals 5, I get 15. It doesn't matter. 15 times 0 is 0. So it works for that as well. All right, and here we're just going to set each of the factors equal to 0 and solve accordingly. So here x would be equal to 4, or subtract 7, 3x equals negative 7, x equals negative 7 thirds. Oops, thirds. So either of those would be just fine and dandy. All right, so here's some steps. I don't like to, I just listed them here. I don't like to memorize steps, because you should be able to think about this conceptually. Once you think of factoring and the null factor theorem, or null factor law. I don't know why I said theorem. Okay, so here we're going to solve for x. Well, this isn't equal to, I need to set it equal to 0. I got a quadratic here, and our first inclination should be, well, we should say, okay, can I take the square root of both sides? Well, I could, but I still have an x involved, and so I'm not going to know what x is equal to. So I'm going to subtract 3x from both sides. Then I'm going to factor like a crazy man, and then either one of these factors, these two things are factors because they're being multiplied together to form another number. So here x equals 0, or x minus 3 equals 0. So x equals 0, or x equals 3. There we go. Illegal canceling! So if you just looked at that example there, you might be inclined, well, why can't I divide both sides by x? Well, here's the reason. We'll have x equal to 3, which is one of the solutions, but it eliminates the possibility, or the other solution, not the possibility, the other solution that x is equal to 0. So you can't cancel a variable that is a common factor from both sides of an equation unless we know that the factor cannot be 0. Okay, so we must be aware of that. All right, so now here we go. I need to set this equal to 0, so I'm going to subtract 28 from both sides, and that is equal to 0. So factoring this, x equals 0. So I'm thinking of factors of negative 28 that when combined give me a positive 3. So I could do, 7 times negative 4, that equals negative 28, so that's cool. And then 7 plus negative 4, that's equal to positive 3. Booyah! So I'm going to have a positive 7 and a negative 4. I mean, you could have done negative 7 times positive 4, that equals negative 28, but negative 7 plus 4 equals a negative 3, and we needed a positive 3, so that's why that one doesn't work. Anyway, that's the thinking that you should be going through with factoring of a quadratic when it has a coefficient. The squared term has a coefficient of 1. So now we have x plus 7 equals 0, or x minus 4 equals 0, and so we get x equals negative 7 or x equals 4. Isn't that wonderful? All right, let's see what we got going here. Oh, 5x squared equals 3x plus 2. I'm going to set it to equal to 0. 5x squared minus 3x minus 2 equals 0. So here you can guess and check by doing, here, let's go over, well, no, let's split the middle term first. Okay, we'll do that method. So to split the middle term, I take my a times my c, because we're in the form ax squared plus bx plus c here. So a times c would be 5 times negative 2 is negative 10. So I need factors of negative 10 that combine to give me a negative 3. Well, how about negative 5 times 2? That gives me negative 10. And then negative 5 plus 2 equals negative 3. So that hits both of my requirements. So I'm going to rewrite negative 3x as minus 5x plus 2x. And then, of course, I still have the minus 2 equal to 0. So there's nothing magic going on here. It's just that negative 5 plus 2x is equal to negative 3x. We just rewrote negative 3x a bit of a different way. So from there, we're going to concentrate at two factors, or two terms at a time. And it does not matter if I had put 2x here and negative 5x here. It would still work out swimmingly. So if I look at these first two terms, they have a 5x in common, and then x minus 5. No, x minus 1. What a dinkus I am. X minus 1, so sorry about that. Here we have a 2 in common, plus 2 times x minus 1 is equal to 0. And I knew I had made a mistake because once I said x minus 5, I looked ahead and realized, ooh, I'm going to factor out a 2, and I'm going to end up with an x minus 1. Well, in order for this, you know that this method is working properly when you factor out something from the pairs of two terms, or the pair of two terms. This must be the same, the x minus 1, because now you have only, instead of 1, 2, 3, 4 terms, you have two terms. You have this guy, and both of them have x minus 1 in common, so you're factoring out x minus 1 from this expression, and you're left with 5x plus 2, just like any other factoring. So x minus 1 equals 0, or 5x plus 2 equals 0, and then we get x equals 1, or x equals negative 2/5. So then the other way is just to immediately do a little bit, I'm going to say educated guess and check. You know that this is 5x and this is x. and you need factors of -2 that combine to give you, well, no, you need factors of -2, and you can't do the combination thing because of this 5 thing. So that would be 5x plus 2 and x minus 1. Why? Because 5x times -1 is -5x, and 2 times x is positive 2x, which gives you the -3x. And then you would arrive at the same solution as before. All right, last example. Here we're going to solve for x, and this is going to require cross multiplication. What is cross multiplication really? Well, it's really multiplying by the common denominator of both rational expressions here for x. It's just a shortcut for that. It's not some magic thing. So 4 times 9 minus x is equal to x times x plus 5. And let me show you why that's true. I'm going to multiply. This is what's really happening here with cross multiplication. I'm going to multiply the entire term by 4x, or the entire expression. Well, 4x times this guy, the 4's are going to cancel, and I would be left with, here, let me write that out. So I would have 4x times x plus 5 over 4 equal to 4x times 9 minus x over x. And let's see what happens here. So 4, 4, and I get x times x plus 5. And then the x's cancel, x, x, and I have 4 times 9 minus x. Does that look familiar? You bet it does. It's the same equation that you have here. Cross multiplication is just a shortcut for doing this. All right, so we have 36 minus 4x equals x squared plus 5x. I'm going to bring all this over here so my squared term remains positive, and I get 0. That's a horrible 0. 0 equals x squared plus 5x plus 4x is 9x minus 36. So then that's going to factor, let's see, factors of negative 36 that give me a positive 9 would be a positive 12 and a negative 3, right? 12 times 3 is negative 36. 12 minus 3 is positive 9. So then I have 0 is equal to x plus 12, or 0 equals x minus 3. Therefore, x equals negative 12, or x equals 3. All right, hope you enjoyed that. Good stuff there. Let's check back in and see what's going on with the summertime sadness. Although summertime is never sad if you have mathematics as your companion, which of course you should have as your companion at all times. With that, I will say, I am out.